So we did most of 8.5 last class. We're going to finish off 8.5 today, basically by just summing up the unit, okay, or excuse me, the last 3 sections. So we have this graphical organizer. We made one the other day, didn't we, for 6.4? Yeah. Okay. We're going to make one a little bit bigger today. So our biggest shape we're going to talk about is a quadrilateral. Yes, we could zoom out bigger and call it a polygon, but all of the shapes we're going to talk about, 6 shapes today, are all quadrilaterals as well.
Is that an A as well? Or is that a D?
You look like you were being kids with soccer balls on purpose.
R-I-L-A-T.
What letter, buddy?
The one that looks like an A.
Okay, well, the one after the L or the one after the U or...
The one after the L. Like the first L.
That's an A and then a T. Mr. Crosby was kind of...
I don't know which letter you're talking. You're not helping me out, buddy.
R-I-L, 2 A's.
R-I-L-A-T-E-R-A-L.
It kind of looks like an A. I'm not gonna lie.
Okay. I can see what you're saying there. All right. So from quadrilateral, we're going to have 3 different drop downs, so to speak. Our first one is going to be parallelogram. We did one of these the other day, right? We're talking about parallelograms. Right?
Yes.
Okay.
God, we love the grand
You
pattern.
know what?
Gosh.
Haven't seen Mr. Crosswell write this yet?
Gosh. Please.
Gosh.
Thank you. Okay. Now, parallelogram. The next most specific thing we have was from there,
Square,
rectangle
and rhombus.
and rhombus.
Rhombus.
Rectangle and rhombus, they were on even playing ground, right?
They held hands.
They held hands, and what happened when they held hands?
Baby.
And what was that baby?
A square.
Where?
Perfectionist.
A square, which is everything from the previous ones.
Gosh,
No.
we love the grandpappy of all
Yes.
shapes.
Mr. Crosswell.
All right, not right now, buddy. All right. Then we have this other branch now. We have another branch that we noticed last time that's not a parallelogram. Instead, it's a trapezoid. Parallelogram had both pairs of opposite sides parallel. Trapezoid had how many pairs of opposite sides parallel?
1.
Just one, and exactly one. And then what was the more specific type of trapezoid, though? The isosceles trapezoid. It said, hey, this is a normal trapezoid, but the legs are congruent. And thus the diagonals are also congruent to this one.
Give Instagram, Mr.
Hmm?
Crosswell. Give Instagram.
No.
I do.
All right. Then our last branch, which doesn't fit into either of these 2 categories. Kite.
We got the disappointment child.
So, yes. So there's 3 different branches off of this. The first is parallelogram, and rectangle, rhombus, square are all more specific types of parallelograms. Then we have trapezoid, which is not a parallelogram. It can be one or the other. Never both, because they don't meet up. Unlike rectangle and rhombus, it can be one or the other or both when it's a square, because they meet up again. Trapezoid goes to isosceles trapezoid, the next most specific thing. And then another branch, which can't be either of these other 2, is kite. Now, our main basis of how we said which one was which was the number of parallel sides. How many pairs of sides were parallel on parallelograms? Both pairs, hence the name. Can you put it away? How many pairs of sides were parallel on a trapezoid? 1. How many pairs of sides? None. Okay? Question on that?
Kite was just a disappointment.
Yes. All right, if we go into the very, very back of these notes.
Disappointment child.
Your $5 is falling out of your pocket.
Yeah, thank you for telling him, actually.
Oh. Yeah.
Okay. Here, we have some different properties we're going to talk about. We filled out a table similar to this, right, but much smaller. This involves all 6 shapes here.
I don't think we filled out the other table.
We did in the homework for 6.4.
Yeah.
So if you notice in this table, it's broken down into 3 categories. The first category is talking about sides. Second category, talking about angles. And then this third category is talking about diagonals.
I love how it got smaller.
Yeah, there's less facts about those. So, for these shapes, raise your hand if you can tell me which of these 6 shapes have all sides congruent. Seth.
Rectangle, rhombus, and square.
Close. I agree with rhombus and square. Rectangle does not necessarily have all four sides congruent. Can it have all four sides?
Yes.
Sure, when it's a square.
And a rhombus.
But could a parallelogram also have all four sides congruent? Yeah, but it's not always. So only a rectangle, or something, only a rhombus and a square always have all four sides being congruent, okay? Christian? No, but it could, but not always. This is an always true statement. Which of these have both pairs of opposite sides congruent? Both pairs of opposite sides are congruent all the time. Bailey?
I know. Is Isosceles Trapezoid one of them?
Not quite. Isosceles Trapezoid have the legs congruent, so one pair of opposite sides, but not both.
Ah, right.
Okay, thanks for putting that out there, though. Anyone else? Dylan? Okay, a square does fit into that as well as some other shapes. Okay, a rhombus has both pairs of opposite sides congruent as well. Rectangle. Okay, Dylan. Any others?
Parallelogram.
Thank you, Dylan. Dylan, yes, parallelogram. If it's true about a parallelogram, is it automatically going to be true about a rectangle, rhombus, and square?
Yes.
Yes, because they're all types of parallelograms. Okay, so all four of those will have both pairs of opposite sides being congruent. Exactly one pair of opposite sides are congruent. Not two, not zero, exactly one. Bailey?
Is this an isosceles?
This is the isosceles trapezoid. Okay? This is the isosceles trapezoid, and that only. Two pairs of consecutive sides are congruent.
Rectangle.
Nope, rectangle is not the consecutive sides. Okay? Dylan?
Square.
Nope. Square has all the sides congruent. So I guess technically it could in a weird way, but we don't say it like that.
That's lame.
Okay? Billiam? Nope. Trapezoid, a normal trapezoid doesn't have any congruent sides. Quentin? Nope, not a rectangle either. Elizabeth? Kite. Kite is our answer for that one. Kite has two pairs of consecutive sides being congruent.
Finally won something.
Yes. Both pairs of opposite sides are parallel. Elizabeth? Say that again. Square is true. That's true for some others as well. Seth? Parallelogram. Now, if it's true for parallelogram, hence the name, what else is it automatically going to be true for?
Rhombus and a rectangle.
Rectangle, rhombus, square. Is it true for kite trapezoid and isosceles trapezoid? No.
Again, disappointment, children, and grandchild.
Yes. Exactly one pair of opposite sides are parallel. Exactly one pair. Okay? Dylan.
I'm thinking it's, wait. Sorry. That's also the structure.
Okay, that's one of them. Elizabeth, you got the other one? Nope, rectangle and square have both pairs of opposite sides parallel. Not exactly one. London? Trapezoid. Both trapezoid and isosceles trapezoid have exactly one pair of parallel sides, and it's the bases that are parallel. So that does it for our sides. Now we're on to angles. All four angles are congruent. What shapes is that true for? Seth?
Rectangle and square.
Rectangle and square. All four angles are 90 degrees in both those.
Why do you switch color?
To differentiate between sides, angles, and diagonals. Both pairs of opposite angles are congruent. Both pairs of opposite angles are congruent. Quentin? Okay, rhombus does fit in that category. Elizabeth? Parallelogram. It's true for a parallelogram?
Rectangle and square.
It's true for rectangle, rhombus, and square. They're descendants of parallelogram, right? Things that are also parallelograms. It's not true for kite trapezoid, isosceles trapezoid.
Disappointment, child, and grandchild.
Yes, exactly. No more, no less. One pair of opposite angles are congruent. Billiam? Not quite. Isosceles trapezoid have the base angles being congruent. London? Kite. And it's the angles between or separating non-congruent sides. Okay, two pairs of base angles congruent. Go, Seth. Isosceles trapezoid have the two pairs of base angles being congruent. But not the regular trapezoid.
Never.
Which of these shapes have the perpendicular diagonals? Dylan?
That is a trapezoid, right?
Not quite. Not a trapezoid. Seth?
Kite.
Kite's one of them. Kite's not alone this time.
Finally.
Seth?
Square.
Yep. It's one of them.
Rectangle and rhombus.
Just a rhombus. So it's not true for a rectangle, but it is true for a rhombus. And if it's true for a rhombus, then it's also true for a square. And it's true for a kite.
Yay. Kite's not a disappointment.
Yes, finally. Diagonals are congruent. Which of these shapes have congruent diagonals? Elizabeth?
Would it be all of them?
Not all of them, nope. Billiam?
Rhombus.
Rhombus is not one of them, actually. Seth?
Rectangle and square.
Rectangle, and thus square. And there's actually one more.
Isosceles trapezoid.
An isosceles trapezoid.
How come the child of the trapezoid is less of a disappointment than trapezoid?
Because it's better.
It's new and improved. The last one that we have, diagonals bisect each other, aka they cut each other in half. Okay? Seth, what are you thinking?
All of them parallelogram.
All of them but parallelogram? Oh, I don't think it's the other 5 shapes. Kenny?
It's just parallelogram.
Parallelogram? No, if it's parallelogram, what else is it though?
Rectangle, rhombus.
There we go. So it's those first 4. It's a parallelogram family branch. Not the others. Okay? Remember, when something's true for the like kind of the parent figure, so to speak, like the parallelogram, it's going to be true for the ones that fall underneath it.
The grandpappy.
Just because it's true for a square doesn't mean it's necessarily true for a rhombus or a rectangle. Okay, so it has to be true for one of them. But there you go.
This crossover.
Yeah.
Want to know why they call the isosceles trapezoid 2.0?
Why is that, buddy?
There's 2 sides are congruent.
Ooh. All right. Any questions on this?